Hey guys, welcome to the next part. This is questions 23. We'll start here and see how far we get. A 10-foot ladder rests against the side of a home. So that's my 10-foot ladder. It's 7 feet away from the base. And here's my home. What angle does it create? So we're looking for a SOHCAHTOA type question, obviously. So we put our eyes on the prize right here. And we have the hypotenuse, which across from the 90, and adjacent. So we're going to use the cosine of x equals adjacent over hypotenuse. To get cosine alone, we're going to use the inverse cosine, and that should get us equal to our value. So shift cosine usually on our calculator, 7 divided by 10. We get 45.52, by the way, that's what it should kind of look like in your calculator. So 45.6 degrees. All right, moving and grooving. Okay, so here we have the law of sines and cosines. So for law of sines and cosines, you need two opposites for this one. Since I only have the two angles, I'm going to add those two together to get 136, subtract from 180 to get my other angle, 44. And now I have two sets of opposites. I have this angle and its opposite side, and I have 37 and its opposite side. And so all I do is do the sine of the angle, 44, over its opposite side, equals the sine of the angle over its opposite side. We cross multiply, we get 17 times the sine of 44 equals x times the sine of 37. Then we divide by sine 37. And so this right here is what x equals. So to put that in the calculator, I'm going to do the top part first, 17 times sine 44. Hit enter, and I get about 11.8 there, if you can see. Not the best lighting, there you go. And then divide that by sine 37, and we get 19.6. And that makes sense. 44 is bigger than 37, so 19.6 is bigger than 17. I like that. Law of sines, we only need one set of opposites, so we have those two. So I'm going to put the x squared over here, and I'm going to put way over here the cosine of 113. And I get to fill in the rest with my a and b squared, my b and c. So it's a squared equals b squared plus c squared minus 2b times c times cosine of a. So I'm going to get 29 squared plus 21 squared minus 2 times 29 times 21 times the cosine of 113. So the really cool part is I can put all this in my calculator at one step. So that's 29 squared plus 21 squared minus 2 times 29 times 21 times the cosine of 113. That ends up being about 1757.91. That's obviously way too big for x, but I still have to square root it. I leave it in my calculator just like that, and then I hit square root of the answer to get my value of 41.9. And that actually is reasonable. 113 is by far the largest angle, so it should be the biggest side over 29, so I'm happy with that. One exterior angle. So all we have to do is take 360 and divide it by the number of sides, because there's 360 exterior. And if we divide that, we get like a funky number, but it's about 8.6 degrees. The measure of one interior angle, I'm going to have to do the sum formula and then divide it by the number of sides. So I can do that. So my computer is giving me all sorts of updates, but not right now. So I'm going to put 32 minus 2 times 180 divided by 32. So the top's actually going to evaluate to the sum, which is 5,400. And then once I have the sum, I can divide it by 32. And when I do that, I end up with about 168.75 degrees. Find the sum of the interior. This I just use the formula, 28 minus 2 times 180. So that's going to be 26 times 180, which becomes 4,680, and then the sum of the exterior, no matter what the side, doesn't even matter. It's always 360. Okay, the sum of the interior angles of a regular polygon is 2,340. So what I can do here is I can actually take the sum of the interior angles formula and set it equal to that. And here I'm just going to get rid of the 180, so I'll divide by 180. And if I get that, I should get 13. And then add the 2, it equals 15 sides. 31's a pretty good little trick here. We have the interior angle of a polygon is 165, so how many sides? Well, if you recall, the interior and the exterior, those actually add up to 180. So if the interior is 165, the exterior would be 15 degrees. The reason why I know that, or why that's important, is because the sum of the exterior is 360. So how many times does 15 degrees fit into that should tell me how many sides I have, which is going to be 24 sides. The measure of one exterior angle of a regular polygon is 12. How many sides? So I do the same thing here because I already have the 12 degrees, and we end up with 30. So we get 30 sides. All right, this one has the 12 in the wrong location here. It's been floating. So I'm going to break this up. That's going to be 12 times 13, which is 156. So I just did 12 times 13, base and height. And then this is 12. This piece must be 9 because 12 plus 9 is 21. And 9 times 9 is 81. And then add those two together, and we should get 237. 34. This should have a 90 degree there, but area is base times height, so it's just 8 times 12, which is 96. Moving on. So we get to our first regular polygon here, which is a heptagon. Heptagon is a 7-sided figure. The formula is 1/2 apothem times perimeter. Now the cool thing is they gave us the apothem of 5.58. I just have to find the perimeter and divide it by 2. Well, perimeter should be the side length, 14, times the number of sides, which is 7. So the perimeter is 98. So I multiply by 98 and divide by 1/2. So if I multiply all this together, 1/2 of 5.58 times 98 should give me my answer of 273.4 square centimeters. This is a triangle, so we're going to find the area of the triangle, which is going to be 1/2 base times height, which is 1/2 25 times 14. And so that's going to end up being 175 square units. I don't know what the units are, so we could do square units. You're not going to really have to worry about units because it's a multiple choice test. All right, find the area of a regular hexagon. So I'm going to kind of cheat here. I already did this one. So I'm going to show you what I would do. So here's the formula, 1/2 apothem times perimeter. It's a hexagon, so I'd find the perimeter first by doing 6 sides times the side length of 8 is 48. So I plugged in 48 over here for the perimeter. Okay. Next, I have to find the apothem. To find the apothem, I can draw a hexagon, break it into 6 triangles. Remember, it's 360 degrees all the way around, so if I divide it by 6, I get 60. When I draw that apothem in, it's going to cut the 60 in half to give me a 30. It's going to cut the side length in half to give me 4, and now I have a special right triangle. Across from 30 is L, across from 60 is L rad 3, so if this is 4, this is 4 rad 3. So we get my apothem here, right there, 4 rad 3. And then we just do, in an exact form, we leave the rad 3 over here, so it's going to be 1/2 of 4, which is 2, and 2 times 48, which is 96. So that's how we would do it. If you have your flip book, we went over these problems in specific. All right, find the area of a trapezoid. Area equals height, base 1 plus base 2, all divided by 2. So that's going to be 10 times 13 plus 15 divided by 2. 13 plus 15 is 28 times 10 is 280. So this should be 280 divided by 2. We get 140. Again, square units. That's a U, by the way. All right. Find the height of the trapezoid given the base of 10 and 18. Well, we have the formula, so I'm going to plug in the area of 126. There's the we plugged everything but the height. So I can multiply by 2 on both sides. So 126 times 2 is going to give me 252. Equals h, and then that's 28. So I just have to divide it by 28. And we get 9 for h. Alright. The area of a rhombus has a perimeter of 40 and one diagonal that measures 8. So if we draw a rhombus out, all the sides are congruent, so it should be 10 for every side. The diagonals bisect each other, so if that's 8, we really have 4 and 4. And they do form 90 degrees, so I can find x right here by using Pythagorean theorems. 4 squared plus x squared equals 10 squared. If you solve that correctly, x equals about 2 rad 21. But 2 rad 21 is in there twice, so my formula of diagonal 1 times diagonal 2 divided by 2 is actually going to be 8 times 4 rad 21 divided by 2. And that's because 2 rad 21 times 2 is 4 rad 21. And for that one, we'd end up with 16 rad 21 square centimeters. Number 41 is really easy. Use the same formula. I get 14 times 10 divided by 2. It's going to give me 70 square units. Number 42, also pretty simple. Area and circumference. If the diameter is 24, the radius is 12. Circumference is area is pi r squared. Circumference is 2 pi r. So 2 pi r is going to be 24 pi. And this is going to be r squared, so that's 12 squared, 144 pi. And the area of a rectangular prism volume equals big B times height. Now, in this shape, I can use lots of different ones as my base figure, but I'm going to use this guy, a 3 by 4 rectangle. So the area of a 3 by 4 rectangle is 3 times 4, and that makes the height 9 here. And so we essentially multiply all those values together. 3 times 4 times 9 gives me 108 cubic centimeters. Again, we're going to use the same formula, big B times h. This time, we have to pick the triangle. We can't pick our poison here. So these are my two congruent parallel figures, and my height is the distance between those. So the area of a triangle is actually 1/2 base times height. So I'm actually going to do base times height divided by 2, and then multiply it by 19. If you plug all that in your calculator, you should get 1,140. Find the volume of the cylinder below. So this is volume equals pi r squared times height. So the r is going to be half of that, which is 5. So you can get pi 5 squared times 14. And that's going to end up as 350. And we can leave it in terms of pi. That's going to be cubic units. This is almost the same formula. We just have to do 1/3 pi r squared times height. We have 41, and this is a slant height, so I have to use Pythagorean theorem here. So that's 40 squared plus x squared for a radius equals 41 squared. And so if we do that correctly, we should get our value of r is 9. So we end up with 1/3 pi 9 squared times 40. And so that would be 81 times 40 divided by 3. So I get 1080 pi cubic centimeters. Alright, this is a pyramid, which is kind of like big B times h. We just do 1/3. The base figure is an 18 by 18 square, so I'm going to do 18 times 18. And the height here is 20. So let's do times 20. So 18 times 18 times 20 divided by 3 is 2160 cubic centimeters. Alright, find the volume of a sphere that has a diameter equal to 24. Well, our volume is 4/3 pi r cubed. R is going to be 12, so we'll do 4/3 pi 12 cubed. And so 12 raised to the 3rd power is pretty large number. So I'll show you how I do it in my calculator. 1728, then I multiply that by 4, divide it by 3, and then slap on pi. And put on my units. Lights go down. The lights went out. Let me get them back on. Ooh, there they are. Alright, 3 more. Write down the scale factor, surface area, and volume. This is pretty easy. 1 dimension, 2 dimension, and 3 dimension. Okay. The surface areas of 2 similar solids is 16 to 49. Find the other. So I'm actually going to kind of show how I normally like to set this up. So these are my different guys. So this is 16 over 49. To go from here back to here, I have to actually square root my A or B value. So square root of 16 is 4, square root of 49 is 7. So that gives me that value. And then to go from AB to this, we have to cube our values. So that's going to be 4 cubed, which is 64, and 7 cubed, which is 343. Okay. So now we're given, again, we have our A to B is given to me as 9 over 12. I'm going to always reduce that. I think that's going to reduce to 3 over 4. So we're going to use 3 over 4 for my A to B. And I'm dealing with volume, so I want to make it all the way up to this guy. And again, we stated that to get from there to there, we're going to have to cube it. So 3 cubed is going to give me 27, and 4 cubed is 343. So there's my volume ratio. I have volumes. Gosh, they like to ring the bells. And so we're going to do cone A, which is 108, over cone B. So 108 over x. And we cross multiply that, which should give me 27x equals this very large number. And then when I divide, I get 256 cubic inches. And that's it. Alright guys, thank you.